Hello there. Today we'll be doing an advanced graph problem. It's very similar to min cost to connecting all points that uses the prim algorithm. This is going to use Dijkstra's algorithm, which also uses a min heap. I learned about this through Neetcode. I guess there's another solution here, right? Well, it looks like there is no Dijkstra. Oh, there it is. Dijkstra's algorithm. So basically, same thing with Prim's algorithm. We're going to use a min heap and hold on to all the minimum points, and then find out like the, the 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 minimum time needed to visit all the nodes. I mean, it's possible that we can use this particular method to get to our answer, but the way we do it here, this is using points, and those are using nodes and edges. So that's the only difference here. So let's do it. So first things first, we need an adjacency list that is going to be a default dictionary, and that pulls in that holds all the from our starting node to our target node and the time. So for start, target and time in times, adjacency list of start dot append target and time. With that, we have appended our item to adjacency list, and we're going to create a min heap now. The min heap is going to start with our time and then our targets. The reason for that is because we need to use the time to check for our to create this min heap, to use the minimum amount of time needed to get to a particular location. And once we get that particular location, then we can mark that as the amount of time needed to take that we need to take to get to that location. So visit it. We're going to create that as a set, and then we're going to create a min time equals 0. So that's our starting min time. So while min heap and the length of visited. So what visited is that we want to set that to make sure that once we've found all the items, we can quit because, well, we visited all the nodes in the minimum amount of time because we used the min heap. So here we're gonna look at time needed, and target equals heap q dot heap pop and the min heap. This is gonna grab the smallest item, time needed, and we're gonna add that to our visited targets. One of the things is that you want to ask is that what if we have visited that node already and it's inside our heap? Let's say we have something that's already there that is going to be needed. Well, what's going to happen is that our min time equals the max of min time. Well, that will not take care of it, will it? So let's take care of that. So if target in visited, let's continue because we're going to remove it. So then for our neighbors in and time in our adjacency list, which is going to look at our current target, what's going to happen is if neighbor not if it's in the visited, then we can continue. That means we're not going to add that any longer to our set of targets. I mean, instead of our heap where we can visit them, and then if it's not in the visited, then what we're gonna do is adjacency. We're gonna set our min heap. We're gonna do a heap push. So heap queue dot heap push our min heap, and we're gonna push into our min heap our time. So time needed and plus time and the target to get to that target. That's not a very good. So I think time to neighbor makes a little bit sense. Makes more sense. And instead of time, is a time to target. I think that makes more sense instead of time needed. So we get to time to target plus time to the neighbor. That will be our total time. And with that, we can return our minimum time needed to get to our location. Heap queue is not right. It's heap queue. That's right. Got 3 items. Weird. What happened? Let's see. Right here. We need. It's one whole thing. And we have the wrong answer. Let's see what's wrong. Okay, so right. So if length visited equals n, else -1, because if it does not reach the amount, we should return -1. But this is not the case here. We're returning output as 0. The min time is not updating properly. Time to target. I'm not sure. Oh. Exactly what's wrong here. Wow. So nothing's getting into the visited. Let's do some print statements here. Okay, so it looks like we just go straight through this, and I don't think this should change anything. Yeah. Weird. Yeah, I don't see anything that's wrong with this currently. I'm not sure what's wrong. So the min heap looks like it has the time and the neighbor. Neighbor is 2 for some reason. But that is not right. We're not supposed to go to a target. We're supposed to go to our neighbor. Okay, that looks good. Let's submit. Great. It looks like we have solved the problem. I'm sorry it took so long. It was an interesting bug. I think debugging is important, and looking at that is something to learn, and hopefully that debugging lesson was a good lesson for all of us, to just check what's inside our data structures and which data structures. So hope you learned something today about using min heaps to grab the shortest distance, as well as how that is applied here in our using Dijkstra's, and also in prims, which is pretty much the same. Instead, we have distance here, and that's in a neighbor, and everything's exactly the same, pretty much. But for one, we're getting min time, and the other one, we're getting the total, well, min distance. So I don't really know how different this is. So hopefully this has helped you, and if you enjoyed the video, like and subscribe. And you want more, check the link in the description below. Thank you very much. Have a good one.